To our discussion. Right. Just now we learned about proof over POW. Okay. You know how it works. And what's the main problem of this one? Power consumption. Power consumption. Everyone's trying very hard, okay, to find out the answer. This will require a lot of computational power. Okay, you use up your electricity. Right. So to solve this problem, okay, we move to another alternative, which is called proof of state. It is used for the same purpose. Used for the same purpose. What's the purpose? To get a consensus or agreement on the state of the blockchain. That means the consistency in your ledger, in your record, right? Same thing, they are solving the same thing. Okay. Bitcoin use proof of work, and until now there is no change, still proof of work. Okay. And another blockchain platform, which is your focus, right? Ethereum. Okay, Ethereum is also originally last year, until last year, they use proof of state, proof of work. Okay, and starting from last year, okay, they already migrated to proof of stake because they want to solve the power consumption problem. No good. It's no good for the environment, right? Proof of work. Okay, Ethereum before that also proof of work one. Okay, starting from last year, they have finished to migrate to proof of stake. Okay. All right. So why you want to migrate? Okay, power consumption. But how we can actually? Okay, what's the idea to make sure the new alternative, let's say proof of stake, is not going to have this power consumption problem? Okay. So in the new consensus protocol, you should make sure one thing: if you don't want to have this power consumption, high power consumption, you want to make it energy efficient. This is our ultimate goal, right? If not, why we want to change? Okay. So you know how proof of work now, and there's something there that causing the problem of power consumption, right? So may I ask you, have you spotted? Have you identified the main thing inside proof of work causing this power consumption? Our friends, this one. Maybe I ask you this question. Okay, so what is the thing we have to talk about proof of work? You think, just so you know how proof of work, right? Okay, what's the thing that make it very power consumptive? A lot of electricity needed, a lot of computational power needed. Which part?
Device.
Huh?
Hardware device.
Hardware device is the one that causing the power consumption. Of course, you need the hardware, right? But so you use the hardware to do what? What's the key thing that you do in your proof of work? You are solving the mathematical puzzle, right? By try and error, right? Okay, but this is needed because I don't want you to find out the answer so easily. Only one guys will be able to propose first, right? Okay, this is important. Okay, but this is the point okay, that making your proof of work very power consumptive. Okay, so the idea is very simple. If you want to improve this proof of work, what we can do is very simple. So the idea is, hey, don't calculate lah, correct not? Don't try and error lah, don't do the mathematical puzzle lah, correct not? Okay, if you still do the same thing, then there won't be any improvement one. Still very power consumptive one, use a lot of energy one, correct not? So the idea is very easy. Everyone, throw away this mathematical puzzle. I don't want to see anything related to mathematical puzzle again, right? In my new proof of something, in my new consensus protocol. Okay, I don't want to do this. Then the question comes again. If I don't do like this, how I get everyone to agree? That block is the block that everyone is going to add into your ledger, right? The question comes back again, right? Okay. Just although it's power consumptive, but there is a purpose of doing that, right? I say, oh, the solution, we want to protect the environment. Hey, throw away this idea, don't do the calculation. And how to do it? So, inside proof of stake, okay, if you look at the keyword state, okay, then you roughly can know how it works already. I hope you know what's the meaning of stake, okay? If you are gambling, of course you know lah. Okay, so the idea is very simple. You stake money. Whoever would love to propose a new block now, okay, you stake money. You stake as much money as possible. Okay? I look at your money only. Do you love money? Anyone to know money? Please take up a wallet and pass it to me. Okay? Yes, based on this, okay, you want to get money, first you stake your money. Your reward, if you want to get reward, by proposing a new block, you put the money there. Okay, I will select from those. Who stake, okay, most money there. Okay, okay. So I will ask you to become someone that eligible to become the block proposer. Just now in this proof of work, it doesn't limit anyone. Anyone can be a miner, right? I download the mining software, I participate in the network, I can participate in the proof of work, consensus protocol. Hey, try my best to find the answer, right? Everyone can be the miner. Everyone can become the block proposer, okay, to propose a new block. But in proof of stake is different. Even though you have stake your money, this is the design, don't ask me why, okay. So, you must take first. You must take money. You must got money. If no money, no talk. You don't have a chance to propose. Wow, no discrimination. Discrimination. Okay, no money. Don't even come to join our this mining process. They call it mining because no mining. Mining is to find just now, right? Okay, to get reward by solving the puzzles for mining. Okay. They call it validator. They don't call it miner. In proof of stake, we don't call it miner, we call it validator. Validator, okay? We have to validate something, validator. Okay. So the simple, okay. So first, whoever interested, take out your money, stake. Stake means you deposit your money in a smart contract. In a smart contract. Okay. It's locked there, okay. Okay, then you are eligible. Yeah, got money stake, you are eligible. Okay. Now, however, doesn't mean that you are validator, then you will be chosen to participate in the block proposing. Okay, no. You need to wait in a queue. Wait a queue. Okay. And after that, when you have been activated, okay, then you'll be selected. Okay, you'll be selected. Mention here. Is it here? Okay, this one better. Okay, we use Ethereum example. Just now it's a general discussion based on this proof of stake, a general one. Okay, now I use a specific proof of stake using Ethereum to explain to you easier. Okay, so you look at the process. You need to stake money. Okay, and then you need to wait. This is an amount of money that you need to stake minimum, okay? 32 Ether, okay? And then so you need to wait, so you join this activation queue, okay? Because they don't want to have so many validators, you need to queue, okay? Queue first. Okay? So once you have been activated, okay, you can start to do this block proposing already. You can propose a new block already. Okay, you will receive a block from others, transaction from others, right? Okay, this is the same, right? Okay, so here, when you want to propose a new block, okay, so you will assign to a group, right? In Ethereum, they will divide this. Previously is the mining process, new block generation process, new block generation process into slot. Okay, we break it down into slot. Time slot is time slot. Okay. 32 slot become 1 apple. Okay. 1 slot, 2 slot, and then 32 slot. The whole thing is called 1 apple. Not important. Basically, they are time slot. Okay, time slot. Why I want to divide into time slot? Just now I've got a lot of validator. They have got money. They stake the money there. Okay, they deposit the money. They are eligible. Okay, and then I will choose from them. I will randomly. Okay, not randomly actually. Also look at your money you stake. Okay, so the one staking a higher amount of money or cryptocurrency. Okay, you have a higher chance being selected lah. You'll be selected if you stake get a higher amount of money. Alright. So a group of validator will be selected lah, and then they will assign to one time slot. One time slot. Okay. Then for another time slot, they will go and randomly select other validator. If you are not staking any money, of course you cannot be selected lah. You are not validator. You're just a normal node. Alright. Alright. So every time slot will be having an assigned group of validator. Okay. Okay. We focus on one time slot. One slot. Okay. In one slot, you want to propose one new block. Okay. Okay. Who can propose? Since just now I tell you, right? It's a group of validator for this time slot. Oh, not you only. It's a group of validator while having money. Okay. Then someone will be selected from this group of validator. One representative lah. Okay. So this lucky one is lucky. Later on you know why in this time slot. Okay. And among all this group of validator, he is lucky. Okay. That's randomly selected one. Okay. This guy. Okay. With the money stake also. Okay. We'll propose. He has the exclusive right to propose the new block. The rest, diam. Okay, don't do anything. Okay, I will create the block. Whatever transaction I want to include, it depends on me lah. Okay, I will take from a memory pool, from my memory pool. Okay, take. Those coming in will go to memory pool, right? There are a lot waiting there, believe me, a lot waiting. Okay, because Bitcoin cannot handle so fast one. Okay, so just go and beep. Okay, and then no any mathematical puzzle, please. No mathematical puzzle like just now needed. No such a thing. After this selected validator for that time slot completed, building the new block. Okay, so you will ask those group member there. Okay, this is the new block we're going to propose for this time slot. There's no competitor, no. This time slot is already reserved for these few guys to play around. The rest are just waiting for your final result. What kind of new block they will be getting, right? Okay. So the proposer tell the rest, hey, maybe 20 of them. Hey, this is the new block I already prepared. So you check got any problem or not. You do the validation. Okay, and then you do a attestation to say, no problem. Okay. Okay. Everyone need to do a voting. Okay, you need to vote. So I got 20 of you, right? Okay, if 19 of you say okay, then it's okay already. Majority will win, right? Okay. You must check of course. Your job is to check, validate, according to the checklist, what kind of things you need check. And then you vote. Okay, no problem. I'll give you one vote. You also give one vote, or maybe 20 of you all say okay. So I'm very happy already, Okay, so the block that I propose, everyone say okay, then I can broadcast already to the rest of the network, right? Because not everyone participated there, okay. So I need to give to everyone. So everyone will add that block into the ledger. No need to check what nonce is there. There's no such a thing, okay. So the new block mainly come for that lucky guy, a single lucky validator inside that group that handle the new block of this time slot. Okay, that's simple. So do we need any heavy calculation, heavy trial and errors, those things? No need, right? So for the next block, depends on next time slot lah. Let them to count them lah. You are all just handling this few validator only settle for this time slot. And take note, the same validator for this time slot also can handle other time slot one. They are so lucky. They can be selected for other time slot also. Wow, got more chance to earn money, alright? Great enough. Okay, so for this time slot, we focus on one time slot now. Okay, so those validator in that time slot, all will be rewarded. All will be rewarded. If not rewarded, why I want to just do the voting and so on, right? Although the real creator, the proposer is for only for one the selected validator among them, right? But it's fine. Everyone will be, we are working together to propose a new block. Everyone will be awarded. Okay, but the one just now, the lucky one, I say, that propose the block, prepare the block, you get higher portion lah, more money a bit lah. Okay, understand? So there is a calculation the way that they will calculate one. You get how many percent, I get how many, they will divide. All will be rewarded. Alright, so they'll get the transaction fee lah, basically, right? Like because also the block reward still there, but it's very limited lah. They'll come from the transaction fee from the transaction inside the new block. Okay? If inside the block all the transaction fees are high, you're lucky lah. Of course, the block proposer always take the transaction with higher transaction fee for the memory pool to put in, right? We love money, of course we look at the transaction. Hey, this one offer higher transaction, of course grab it and put inside my block, right? So you can get the maximum profit lah, okay, from the transaction fee. Okay? Okay, now it seems good, okay, this way very simple, not difficult. The idea is using validator and not miner. No any mining, no any puzzle solving just now, no try and error, no energy consumption lah. Okay, but there is a risk. There is a risk that some validator will not behave honestly. There is a risk that some of them go offline. Go offline means shut down. You have been selected, you're not doing your job. That is not a good thing, right? Okay. So to prevent, everyone very important, quiet, listen carefully. So to avoid this kind of misbehavior, to avoid those going offline or doing some other malicious things and so on, these are the things that you don't want, right, for the validator, right? Okay, so we must, how we can make sure they behave properly and always stay online, always participate in this process, okay, when we want them. How to make sure they are always there, the machine is always on, they are not trying to do malicious thing, okay, like proposing a multi block lah, submitting contradictory attestation, they vote, okay, and so on. Okay, so the simplest way is, everyone listen carefully, to prevent all these things from happening. In proof of stake, we usually will impose penalty. If you are caught doing all these things, then you will be penalized by taking away your stake or some portion of your stake. Okay, you will lose your money lah. Okay, you will lose your money. This is the simplest way. Okay, we will perform something called slashing. Slashing in Ethereum, we call it slashing. Meaning you will be losing a percentage of your stake Ether. Let's say you stake 20 Ether, maybe a portion will be 3 Ether or 5 Ether will be taken away lah. Punishment mechanism is there. It's very important. Just now the proof of work. Is there any penalty? No, right? You won't be penalized, right? Right now, you are free to propose anything, If you propose, you are the first one to solve the puzzle, first one to find out the node, and if it's not validated by everyone, okay, or some problem in your block and so on, you won't be penalized. No penalization in proof of work. But in proof of stake, yes, I can penalize you because you got money stake, money deposited. I can take away from your deposit. That's why I can penalize you. Minor, you got deposit anything. Want to penalize also don't know what to do. Alright. So remember, penalizations is a very important thing in proof of stake. Yeah. If you want to get your reward, you want to penalize, work properly, work as accordingly and don't go offline okay. Okay, remember, you got reward. Of course, when you manage to propose the agree block, of course you receive reward based on the formula you get how many percent, I get how many percent, and so on. Okay. This is only valid for the validator for that type stock. If you are not involved, you are not getting. Okay. Even though you are validator because you are not selected to participate. So doesn't mean that you stake money you got a chance you must be lucky or stake more money so your chance of being selected higher okay. And also must be properly remember we have penalization like this okay. Okay, let's move on. Now I want to get a better idea about proof of stake and how is it different from proof of work. Okay. So that's why Ethereum want to migrate to this. You know they say how many years to migrate successfully? They plan for 3 years and so on. More than 3 years. Only step by step. They managed to change from proof of work to proof of stake last year only. Just last year, and it tortured me. You know why? Because I need to change my channel. After I'm not teaching this, because Ethereum proof of work so senang. I talk about proof of work in Bitcoin settle, the rest the same. Then they introduce this. I need to go and change. Okay. But you also suffer to learn a new one. But these are the two important consensus protocol you need to learn. Of course, there are a bunch of them. But for your course, you don't need to know others. For example, the practical design, practical Byzantine fault tolerance is also another famous one. Okay, but I'm not going to discuss with you. You just go through on own. You won't expect any question for your final. Don't worry. Okay, there are many. I can't afford to explain in detail for all. I think proof of W and proof of will be sufficient. Let me check the time. Okay, meaning to say I only have a few minutes. Alright. Okay, so this part I'm not going to talk. Okay, so you can Google yourself if you are interested to know more. There are many proof of time elapsed, proof of authority, proof of contribution, a lot of proof of something. Okay, but they are all because we want to have this consensus on what kind of which block to put in our ledger, right? Okay, so I'll skip on. Go and enjoy yourself. This is interesting. This is something you need to know. Because if you connect to our discussion when we come to Ethereum, okay, I want you to be aware of this model in Bitcoin. This is little Bitcoin, okay? So there's something called unspent transaction output. Okay, this is unspent transaction output. Unspent transaction output. Okay, don't need to read, just look at this diagram. Okay, this is something that you might not know. Okay, let's talk about this scenario. We have Alice and Bob. Alice want to send this 1 Bitcoin to Bob. Okay, so this is what happened. Okay, of course you must make sure that Alice got enough money this is very important, money. Okay, so now I only want to send 0.5 Bitcoin, right, to Bob. Okay, okay, so I can actually send 0.5 Bitcoin to Bob from this transaction that I get from another transaction. Someone sent to me, and I haven't spent. Someone sent to me. I haven't spent. So this will become my unspent transaction output. Okay, in this transaction as an input. Okay, and then I put it into 0.5. And this is interesting. You only send 0.5. We have 1. I have 1. I only have 1 Bitcoin. Okay, I can spend 0.5 to someone. What happened to the remaining 0.5? Right? So here in Bitcoin, the design is you must send back to yourself. You must spend. Doesn't mean that you get 0.5 deducted for this unspent transaction output, and then you only send 0.5. Only one sending of your fund. No, you need to do two different transfer in this transaction alone. Okay, even though your purpose is only to send 0.5 to the receiver. This is what you want to do, but you must handle the remaining amount. So you remember, must send back to yourself. You must send back to yourself. Or else you don't know what will happen. Okay, to the 0.5. Okay, hilang. Okay, so remember, this is a very interesting part. Okay, so what I want to say is, in Bitcoin, to know the amount of money, actually they are doing in this way. Okay, this is the Bitcoin one. Look at here. Imagine this is the ledger for Bitcoin, containing all the blocks, all the transactions, so on, right? When you want to know how much money you have for your account you can create, right? Okay, I have account. This is the address lah. Then I want to know how much I have. So what I need to do is, your wallet need to do for you, not you. Your wallet is the one that actually lets you know the balance. So you want to know your balance for your Bitcoin account. What your wallet will do is, it will start from the beginning. See, any unspent is very important. You spend, it's not yours already, right? Unspent transaction output, related to your account. Here got one. Oh, okay. Then 2 years later, here got two. Oh, it's your account is unspent transaction output. Then check. Oh, today got another 10. Bitcoin coming from somewhere, and then this is your unspent transaction. Okay, so your wallet do a conclusion for you. So it will do total out. Just now 1, right? 2 Bitcoin, 3, and then 10, right? 13 Bitcoin. So then you open your wallet. Hey, this is my account. Current balance 13. This is how you get your balance. It's not like your conventional application. You do a query, it will show you, right? Whenever you want to know, you need to ask. The wallet will do the job for you. You can check the ledger, it's fine. As long as this is an unspent transaction output related to your account, it's just a total out. Because unspent still yours. Here also 2 years later one. Okay, also yours unspent okay. Yeah, until today the 10 Bitcoin also yours, right? Unspent, right? So your total should be 13 this way. This is the way, you're not expecting your wallet can communicate with the Bitcoin never using API, and then you actually return you directly for the database or some way and so on, store in the database or data structure or whatever, for the memory or whatever, to give you the data, to give you the answer for your balance. No, you need to see the whole ledger, find the unspent transaction output total. Okay, so this is how you get your balance. Okay, the next part is this one all you can read. Okay, so I mentioned already that there's a limit for the this number of this Bitcoin that we can circulate, right? Okay, so every 4 years we halve and then become 0. So in 2000 140, okay, still long time ago, okay, before it becomes 0 so no block rewards after this, okay, but getting less and less, okay. So it depends on transaction fee per transaction. That's why in blockchain based application you need to pay for transaction, not like a conventional one. Okay, I think I need to rush. Okay, it's okay lah. I think the rest you can go through read on your own. Okay, so because I emphasize today, you need to learn 3 things, right? Still remember? First, what is a consensus protocol? Why it is useful? Why it is important to have consensus protocol? I hope all of you know. Second thing is, what is proof of work? Example, this consensus protocol, right? The most famous one. What's the problem behind? And that's why proof of stake can help to solve the problem of proof of work, right? Okay. So what is proof of stake? How it works? So on. You also need to understand. These 3 things will be now. Okay. All right. That's all. Everyone's no question that we can end. Okay. Thank you.